So, 5.3. Proving triangles are congruent with side, 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 and side, angle, side, and we're going to talk about hypotenuse length. Side, 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 or SSS postulate. That's how you'll see it written a lot, is SSS. Okay? Side, side, side postulate says, if three sides of one triangle are congruent to three sides of another triangle, then the triangles are congruent.
Why did they come up with like a mathy name? Side, side, side.
Math people aren't artistic. We don't come up with things.
Well,
We come up with
artistic.
logic. All the sides are congruent. Side, side, side. There we go.
Wait, should I not say that?
Don't say.
Okay.
Okay. What?
But that was so dumb.
It is common sense, but we have to state it. Don't you love stating common sense?
Artistic.
So side, side, side. Pay attention. Okay, hypotenuse leg. Hypotenuse leg. What type of triangle has a hypotenuse?
A right.
Okay, so what type of triangle do you think this can only be used on?
Right.
Some people will try to use it on others. Don't be one of those. Okay, hypotenuse leg congruency theorem says, if the hypotenuse and a leg of a right triangle, doesn't matter which one, are congruent to those of another right triangle, then the triangles are congruent. Hypotenuse leg theorem. You need a hypotenuse, you need one of the two legs. You got hypotenuse leg. It is what it says it is, hypotenuse leg. See how common sense we use here in math? What?
Cap up the side of your desk.
What is it?
My homework.
No, keep it there. I'll look at it. Okay. The last one we need to talk about is side angle side or SAS. Okay, side angle side. If two sides and their included angle of a triangle are congruent to those of another angle, then the triangles are congruent. Okay, here's the important part about SAS. It has to be a side, an angle, and a side. It's like an Oreo sandwich. Cookie, cream, cookie. Okay? Side, angle, side. It can't be angle A or angle C. It has to be the one that's in between the two sides that are congruent to each other. Okay? Side, angle, side. It's a sandwich, a little cookie sandwich. We all like cookies, yes?
Yeah.
I don't like cookies.
Brady.
Brady, you love everything sugar.
Especially C3 from the vending machine.
Okay. So you have side, 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 hypotenuse leg, and side, angle, side. Okay? Side, angle, side. The angle has to be between the sides. So side AB is congruent to FE, angle B is congruent to E, and side BC is congruent to ED. That means triangle ABC is congruent to triangle FED. Order matters. Remember that. Order always matters in these. Okay? Order matters. Good.
But you don't use it.
So even if I
Okay, I'm gonna give you about 2 more minutes to write this down, and then we're moving on, because like I said, we have lots of proofs to get through today. Yes, sir.
Aren't all these in our like geometry?
They are.
Oh.
They're also on that amsco.com website, and they're also on all the notes that I typed up for you. Lots of places to find them.
Do the slides that you post on Power School work now?
They work for some people. I'm going to have to, what? Yes.
No.
I think I'm going to have to print all of them off and scan them through is what I'm gonna have to do, because I can't translate them into Word, or into PowerPoint documents, or PDFs. Yeah. But they work for some people that have the version that allows
You could just
for it.
screenshot them and then
Oh, yes.
put them in those screenshots.
Yeah, that'll take forever also, but it's another validation.
Or screen record it.
Okay.
And just like.
I don't have a system to do that on here.
Oh, that's so sad. Recording in class.
Mrs. McCain and Mrs. Granger have it because they don't use their Macs when they do that.
How about QuickTime?
That's true.
If you have them do
Can't write on it and do it at the same time.
No, I meant like screen recorded and like, we can pause it and look at it.
You can't do that.
I just
This
have
doesn't have a compatible system with the math.
it.
Okay, prove triangle BAC is congruent to triangle BDC. I need to do a proof. That means I need statements and I need reasons. Okay, statements, reasons. Okay, tell me, what's our givens?
BAC congruent with the BDC.
AC and DC,
Yeah. Are congruent.
okay,
AC,
what
DC?
else?
AB and DB.
AV and DB are congruent. Okay, good. What else do we know? Yes. What?
Since, AB and DB are congruent, the angle is opposite of them.
Okay, good. There's two ways you could solve this, okay? Good. So you can say angle A is congruent to angle D, and then you would prove it by using what?
A theorem.
I could say this. Angle A is congruent to angle D because of the isosceles theorem, right? Isosceles. Or, and then I could say triangle BAC is congruent to triangle BDCY.
Because of the side angle side.
Yes, or, right here, I could go another route, okay? What else could I state after AB is congruent to DB? There's another thing I could state. Do those two triangles share something?
Yes.
What?
A line.
What line is that?
Hypotenuse.
So BC, it's not a hypotenuse, there's no right angle.
You're right.
So BC is congruent to BC. There are no right angles. You don't know you do not know that's a right angle for sure. It is not stated anywhere. You can't assume, cannot assume. So BC is congruent to BC. What is that called? What property is it where something is itself?
Oh, equal,
No, it starts with an R.
Reflective.
equilateral.
Reflexive?
So that's a
Wait,
real
is that
thing.
supposed to go underneath?
No. Listen, there's two ways to solve this.
Oh, two ways.
This is one way, and then at this step you can go to here
Okay.
too. Okay, which then allows me to say triangle BAC is congruent to triangle BDCY. What would I have there? I would have side, side,
So,
side. So you can prove it one of those two ways. Do you see why I'm saying when it comes to proofs, you can do it many ways now? Okay, it's what you see, but
Nothing I'm saying along
Okay.
there.
so it's what you see. So I could either have proven that by side, 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 or I could have proven that by side, angle, side, depending on what you see and what you can pick out from that diagram. That's why on your homework, if your homework ever says, skip this question, it's because I need to read your answer. Or if it's a proof, it could be that you did do the proof right, double check with me tomorrow because we could have done it more than one way, okay? Okay. Okay, prove that angle B is congruent to angle C. First, I need to come up with some givens. What do we know?
BA congruent to CA.
Why?
Because,
It's mine,
It has lines.
It's given.
given. Now what?
the isosceles theorem says
Beautiful. Angle B is congruent to angle C, isosceles triangle theorem, right?
Wait, is that Wednesday,
That's
Tuesday?
it.
Or yesterday?
Yes.
Will that be on the test?
Something like that.
No grading.
So Connor, what it tells us is if the two sides of an isosceles triangle are congruent, then the two base angles are congruent.
Oh,
It also says if the two base angles are congruent, then the two sides are congruent.
was that, is it the converse?
There isn't a converse, it's all in one, it's all wrapped in one on that one,
Oh,
okay?
Yeah, common.
Okay. Prove triangle ABC is congruent to triangle DEF. Triangle ABC is congruent to
Wait,
triangle
what's that?
DEF.
What are givens?
Okay, what's our givens?
AB is equal to DE.
You said AB is equal to DE, good, you put it in the right order.
wait,
Is congruent to DE.
EF is congruent to AC.
EF is congruent to AC. Good. Those are all of our givens. Now
What
what?
is that vibration?
I don't know. Now what?
Feel the vibration.
Now what?
Oh, well, we have a right angle.
You don't know that.
Dang it. How do we not know that?
But we do have enough information already to prove that the triangles are congruent. Why?
Because it's the, if they have all the lines
They're
that
congruent.
run here.
Is it the same side? Side.
Side,
Yeah, that's what I
side,
meant.
side,
Yeah,
side,
that
side,
one.
side.
I do it.
Oh, side, side, side.
So triangle, A, B, C, is congruent to triangle, D, E,
Cube.
S,
Because of side.
No, you can just say side cubed.
what? You have to say side, side, side.
Side cubed.
Just put SSS.
That's to the power of three.
To the power of-
Okay. Here we go. Here's another one. I'll read it to you because it's a little off the screen, sorry.
Yeah.
Bless you.
It says,
Thank you.
AJ, okay, AJ is a perpendicular bisector of KM. Show that the triangle KJR and triangle MAR are congruent. What is our given?
A and J are congruent.
Is
No, doesn't say anything about that being. What's the one thing, one sentence that starts with, what? Oh, perpendicular bisector, so we know AJ is the perpendicular bisector of KM, okay? If we know AJ is the perpendicular bisector of KM, that would be our, what?
Given.
Given. Segment AJ, perpendicular bisector,
wait, are we sure?
It says that.
it says that.
It doesn't look like it.
Yeah.
Connor, we talked about this,
Yeah,
Oh
Connor.
yeah, they're not scaled.
they're not to scale, deal with it.
Yeah, deal with it.
Okay. They're the perpendicular bisectors, yes? What does that mean when I have a perpendicular bisector?
It's the hourglass.
What does that mean, Devin? It's your favorite thing to assume that's there.
Right
Right
angle.
angle.
There we go.
Yay!
So we know that these are right angles, correct?
Yes.
So I can say angle ARM and angle, what goes with
It's
A?
not vibrating. It's the
Okay.
long notes.
J.
No,
What do you call it?
no, K does. And angle KRJ
It's like half
equal 90 degrees, correct?
Uh-huh.
Definition of perpendicular bisector.
Yeah.
Okay.
Hourglass.
It's the definition of a perpendicular bisector. Okay, great. Now, here's the deal. When you are solving for a right triangle, do we have a theorem that goes with a right triangle?
The right
Yes.
side.
Good, yeah.
What is it called?
The hypotenuse,
Hypotenuse?
yeah, wait, hypotenuse leg
Hop-
congruent.
hypotenuse leg. So if I can prove that the hypotenuse, whatever you say. No, if I can prove that the two hypotenuse
Hypotenuse.
are congruent to each other, and that one of the sides is congruent to each other, then I can prove that this triangle is congruent using hypotenuse leg.
Wait,
C.
I like hypotenuse leg again.
One of the two hypotenuses are congruent, and two of the legs are congruent. Doesn't matter which of the legs, as long as it's corresponding legs. So,
Oh, okay.
here's the deal. Now you have to do some thinking back into algebra.
Great.
How can you solve for the hypotenuse of a triangle?
A plus B equals A squared plus B squared equals C squared.
Beautiful. So can I figure out what this hypotenuse is here?
Doesn't it tell you
Yes.
AM is
So what does AM equal?
5?
C squared.
Right, what is C squared? What's 3 squared plus 4 squared?
2 squared plus 4 squared.
Well, what's it?
25, right,
What'd you say?
What's
25?
yeah, 25.
What's the square root of 25?
5.
So AM equals?
Five.
Is that the same as what KJ equals?
Yeah.
Yes.
Yes.
Because they.
That's a lot of work.
Okay. So AM equals 5. We found that by doing the Pythagorean theorem.
That's the word I was trying to think of.
Okay,
Pythagorean.
beautiful. So then, from there, I can say AM is congruent to KJ,
Keep doing it and I keep looking up.
not KJ. it
Yeah,
would be-
same. I'll be
it would
thinking
be
she's saying
JK.
KJ.
Oh, no.
Okay, why are those congruent?
Because they equal.
What would be my reasoning?
Never say that.
What would be my reasoning? If AM equals 5, JK equals 5, it's something where I get rid of the middle. Starts with a T.
Transverse.
Transitive property.
Brady get
We
that?
didn't get it right. We said transitive.
Yeah, isn't that what?
No, we said translative. I said
I said
transitive. You're-
Nice English, Brady.
Yeah.
See, why do they make
Okay.
the words almost the same?
Now,
That's just stupid.
Brady's okay. Brady's okay.
Brady,
Now-
all words are pretty much the same.
I have a question for you. What
This is
else do
America.
we know? This is stuff you have to start asking yourself. What else do you know about a perpendicular bisector? Not only does it create 90-degree angles, it also creates what?
A right angle.
That's not.
What else does it also create?
Interior. Wait, did you say bisector?
I said perpendicular bisectors. What does that mean it also creates?
Right.
He just said it too.
Wait.
Stop thinking angles and start thinking about segments.
Creates a bisector.
What does
Segment.
bisector mean?
Segment KJR.
Two sectors.
Separate
No.
shapes.
Two triangles. Like there's two different
No.
things.
I already said that.
Listen.
So I see that in different lines, right?
No.
That's.
Listen. Stop thinking about angles for a second. Think about the lines. When I have perpendicular bisectors, there are two lines. What specifically
Vertical,
about
vertical.
these? No. Stop. I already said it. Stop thinking about angles.
Yo, let the comment.
Listen to what I am saying before you shout things out. When those two lines cross and they create a perpendicular bisector, yes, we know these are 90-degree angles. What do we know about this segment compared to this segment?
What equals 180?
No. That is an angle still. I don't want the angles. I want to know, how does that segment compare to this other segment where it was split? Oh, thank you. It's the same, which means they are what?
Congruent.
Congruent. Those segments are equal.
Wait, could you say?
It divides it into two equal segments. So, I know if this is the perpendicular bisector, that this leg is the same length as that leg.
That was a lot of effort.
Yeah, you have to think. So, I know that K, that segment KR is congruent to segment MR. Definition of a perpendicular bisector. Now, what can you use to prove those triangles are congruent?
Side, angle, side.
Not side angle side.
The other one.
Oh, side.
Side.
It's
I
the
don't
Oreo
have-
cookie.
I don't have a sandwich. I have this, I have
Side,
this,
side.
and I have these.
Side,
Side by
angle,
side.
right?
Something with the legs.
What was it, Bree?
Hypotenuse leg.
Hypotenuse leg. I have the hypotenuse
Hypotenuse.
and a
I
leg.
swear that's it.
Hypotenuse.
See, I thought it was the Oreo cookie.
No, because they are not in a row.
Here, throw it.
So it's hypotenuse leg theorem. You have to start to do all this stuff by
I did say
yourself.
hypotenuse and I did say leg. I just didn't.
You just didn't connect the dots.
Sure.
Okay.
Yes.
Here's another one. You're gonna pretend this diagram is perfect because I tried my best. It's what? If you have some, I don't have it. It says triangle ABC is congruent to triangle DCE. It wants us to prove that those two triangles are congruent, given that C is the center of the circle. So I'm going to start with my statement and my reason. The only given I have is what?
Oh,
C
yeah,
is
not
the
the
center of the
scale,
circle. Okay. Now, if this is a circle, talk to me about what we know about circles.
They're 360 degrees.
They're 360 degrees. They have what in them? like
Diameter.
diameters and
Radius.
radius, beautiful. And if something comes out of the center, it is a,
Radius.
it's a radius if it goes from the center to one side, correct?
Brady, how'd you get it on?
Beautiful. What do we know about all radii of circles?
There.
What? They're what?
That from KJ?
No.
They're half the diameter, but what else do we know about all radii? Stop talking.
Wait,
There.
wait, I know this.
It's half the diameter, but what do all radii are what compared to each other in a circle?
The same.
They're all the same. So look at those triangles. If this is the center, what else can I come up with off that diagram? If C is the center, what?
Think.
No, don't think.
Yes.
Just say.
So what does that mean?
But you get the vertex line that cuts it down the middle.
Okay, so what can I say about this in comparison to,
Oh, you can say that AC is equal to EC.
Dump water on it.
Because
you would say AC is
Have you seen that
congruent
to
to DC. You would say what else?
that EC is congruent
The EC is congruent to
to
BC, okay? Okay, so now I have that, yes?
Yes.
Now what can you prove from there? Oh, wait, that was, definition, well, you could say definition of circle, or you could say the radii of a circle are all equal. Okay. Now, from there, what do you think we need? We either need another side, or we need that middle angle to do side angle side, or we need another side. Can you prove the other sides are equal?
Wait, isn't it just, I saw something.
No.
No, not even close.
You could, but if I do that, listen, if you prove that those base angles are congruent, okay, using isosceles, I get what you're saying, using isosceles theorem, can I prove the triangles are congruent?
Yes.
Yes.
How?
I have no.
There is nothing that we've learned so far. We've learned hypotenuse leg, we've learned side, 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 or side angle side.
Side angle side.
How are we gonna prove side angle side?
Well, side,
There's no
side,
sides
side
on the
doesn't
triangle.
work. Hypotenuse doesn't work, so it has to be side.
Okay,
angle
tell
side.
me, how do I know that these angles right here are congruent, the ones that are in between those two sides?
They're alternative.
Why are they both equal?
They're
They're
alternative
vertical
interior.
angles.
They're what?
Alternate
They're
interior.
vertical angles.
Just.
They're vertical angles. So I know that angle ECA, no, I lied. ECD,
Why?
Hey,
I know that angle ECD
keyboard.
is congruent to angle BCA because they are vertical. You've got to start recognizing this. Now, I can prove that triangle ABC is congruent to triangle DCE using side, angle, side.
Oh, that's the Oreo.
It's a sassy triangle. It is the Oreo. Okay, does that make sense right there? I mean, now that we spelled it out. Okay. So you have side, angle, side on that. I have 2 more slides.
We got this.
We have.
So geometry
We
is
do
nothing but a
have
big
time.
old puzzle.
We have
Right.
plenty of time.
Here you go. Prove, oh yeah, I gotta label this one, I forgot. Prove SEA is congruent to TAE, and it looks like this. It should say SEAT. SEA is congruent to TAE. Okay, statements,
Yo,
reasons.
that's all I was listening
What
for.
do we know?
S is parallel to AT.
Good. We know that SE is parallel to, it's gonna be
TA.
TA.
That makes AS parallel to ET.
No. Those are parallel as well, you are correct.
Really weird.
Those are parallel as
You have to
well.
what?
But I know something else from that diagram besides the fact that those are parallel. What do I know about those two sides? What?
AS
Mhm.
is the same as ET.
Yes, so
Watch
AS
that for Christmas.
is congruent to ET. Phone home. Aww. Given.
Wait,
Okay.
Could you say
So
parallel?
now you have a side, and what do you know when things are parallel? What do you start to recognize about that?
They will never intersect.
If two lines are parallel and they are cut by a
Anything.
transversal, what happens?
They're equal.
No, it
They're
makes
congruent.
certain things congruent. So here is a line
Mhm.
that is parallel to another line that is
Which makes them
intersected-
congruent.
that is intersected by a transversal.
So they're congruent.
So, think this through before you answer. You already know that this side and this side are congruent. Is there another side that's congruent?
Yes.
What?
I want to say the top and bottom.
We don't know that for sure. We know they're parallel.
You never know.
What do you know? What do they? Do those two triangles share a side?
Yes,
Of what?
the middle,
What's that called?
a transversal.
What's the segment called that they share?
Oh, AE.
AE. So I can say segment AE is congruent to segment EA. Why can I say those are congruent to each other? What property?
The one you taught us.
Side angle side.
It starts with an R.
Reflexive.
Reflexive.
Take it.
Because you taught us.
Now look, I have a side, I have nothing.
I have a side.
Stop talking. I have a side, I have a side, okay? I have two sides. So I either need to prove that an angle is congruent or I need to prove the third side. Is it possible to prove the third side is congruent?
No.
No.
I know.
Okay, what?
Alright, you can do, say that EAT and SEA are congruent.
You could. The problem is that's not in between those two sides. So I want to prove that, you're on the right track. I want to prove that angle SAE, okay, angle SAE is congruent to angle TEN.
Oh, no.
Does that make sense? Yeah. Because now that puts this angle in between my two sides, so I have a sandwich.
That would be, alternate.
But why are these two angles congruent? What's that called?
Alternate interior.
Alternate interior. So now I can prove that triangle SEA is congruent to triangle TAE using what? Side,
Angle side.
angle, side. Okay? What?
What's reflexive?
Reflexive means it equals itself. Remember, it's the rule like 1 equals 1, A equals A, you are yourself. It's a property from actually algebra. AB equals AB.
Wait.
You have to state it.
No.
Oh,
Okay,
like A,
Yes.
C equals
yes.
BA.
Yes. You have to state it. Okay, here's the last one. This takes a little bit of algebra.
Oh my
Hey,
we got it.
Doesn't matter what it is math-wise, you moan. Okay, AB is 1/4 of BC. AB is 1/4 of BC. FE is 15 less than ED. What is BC? What do you know about those triangles right now from the given?
They are congruent.
Why do you know that, Bree?
Because E and F are congruent to B and A, and then angle B is congruent to angle E.
What is that called? Triangle ABC is congruent to triangle FEDY. What is this?
Side, angle, side.
Side, angle, side. So that's my given. Okay. So we know those two triangles are congruent, which means that AB is congruent to what?
AB is congruent to
To FE. And it means that angle B is congruent congruent to what?
Angle
Angle
E.
E,
And it means that that side
Yeah, but what is-
BC
Mhm.
is congruent to what?
E,
Those are all basically givens, yes?
What is it?
Okay, now, from there, let's look at the math behind this. It says, AB is 1/4 of BC. What do you want to represent BC with?
25.
X. Beautiful. X. If AB is 1/4 of BC, what does that mean AB needs to be represented by?
4.
1/4 X.
X.
Okay? If I'm trying to figure out what FE is 15 less than ED. Well, what's ED?
BC.
Beautiful. It's X. So what does that mean EF is?
Negative 15, X.
X minus 15.
That's the same thing, isn't it?
No. So
Great.
it says, what is BC? Well, the only way to solve this would be to set AB equal to what? EF. Now, how do I solve from here? How do you get rid of 1/4?
Minus 15.
Oh,
Or plus 15.
Multiply by,
4.
so that you get X equals, what's 4X minus what? What's 15 times 4?
Is it 75?
4 times 5 is 20, 4, 60? Yes.
4x minus 60.
Now, subtract 4x, right? And you get negative 3x equals negative 60. So what does x equal?
30. Negative 30.
20. So, what is BC?
B, C,
Which was BC?
20. BC.
Oh, yeah.
That's how you're solving.
See, but it went from negative 20 to 20, so how did you do that?
It went from negative 60 divided by negative 3 is positive 20.
3x.
Okay, that is what your homework is over.
Alright.
It is on the board.
Divided by negative 3 is positive.